Good afternoon, everyone. Welcome to our webinar, Cooling Canada's Data Centers Preparing for 2026 and Beyond. This topic was chosen because the onset of AI is mandating that cooling becomes a primary component of data center infrastructure. Let me introduce our panelists. My name is Jacques Morvan. I work for head of business for PLC Group. I'm the head of business development for mission critical facilities. And my co-host is Sean Corcoran. He's Director of Sales, AirSys Power One Data Center Vertical. Before we start, I want to do a bit of housekeeping here. Participant cameras and mics are disabled to minimize background interruptions. We encourage you to drop your questions in the meeting chat. Some questions will get answered during the webinar. Most questions are going to get answered at the Q&A session at the end of the webinar. The webinar is being recorded, and a presentation deck will be shared via email with all attendees. Along with this email, we will send you a link for the recording and also the list of questions and answers. Now, I want to discuss with you, introduce you to PLC Group. PLC Group is a Canadian company with 10 plus years of experience serving our telecom customers with remote monitoring, cooling for small and large facilities. Our customers see us as a trusted partner over three main pillars. First pillar being actionable intelligence, which is an AI-based facilities management platform with predictive analytics and capacity planning capabilities. Second pillar being the BMS, RMS, hardware and software to manage all the elements of your facility. And third pillar being ICT cooling solutions with our partner AirSys. Today's session will focus on cooling solutions for data centers and large facilities. Now I want to talk to you about the PLC AirSys partnership. PLC Group and AirSys have been in a strategic partnership for over a decade to serve the Canadian market. We started in 2015 with highly reliable free air cooling and wall pack units for our telecom customers. We have recently evolved into larger mission critical facility cooling units. Here's a slide showing all the data center cooling products. Most of these are for the part of the presentation that Sean will mention to you guys. I just want to mention there's two units here, the wall pack unit and the Edge One unit. These two units here, they're being used by large facility customers here in Canada, mainly for the power room and also for modular data centers. Go ahead, Sean. You can take over the presentation.
Okay. Jacques, thank you very much for the introduction, and thank you, everyone, for being here. As Jacques mentioned, my name is Sean Corcoran. I am the Director of Sales for AirSys Power One. I have over about 26 years of experience in the industry. And if a lot of you don't know who AirSys is a US-based thermal management infrastructure solutions manufacturer. And the Power One division, which I'm the Director of Sales of, is primarily focused on the precision cooling solutions within that data center space. As you can see, we do have a global footprint with three main manufacturing facilities in China, Hungary, and in North America, specifically in South Carolina. We have numerous partners, distributors like PLC that we work with across the globe. AirSys has been in business for over 30 years, delivering thermal management solutions, as I mentioned. We were founded in 1995 by Mr. Chen, and we've been selling, manufacturing chillers from small MRI to fit into small MRI machines, all the way up to 500 plus tons of product sets. In 2020, we moved our global headquarters from Beijing to Woodruff, South Carolina, where we're investing into a 60 plus campus with over 455,000 square feet of manufacturing space. We've invested over $40 million, into 60 acres. And the first facility we're manufacturing is our 264,000 square foot facility that you see to the top right. with our administration world-class headquarters off to the back side of it. We also have an additional 220,000 square feet or so of space also on the campus that we're going to be expanding into in 2027. This will give us the ability to produce over the 20 plus products that we currently produce within our three divisions, which is Comfort Cooling, Edge One, which Jacques mentioned for the backpack and the Unicool, and the Power One, which is the precision cooling, which is the products that I'm going to be highlighting. Why are we here? It's demanding from the market. We're seeing tremendous growth, significant growth that approximately about 15 billion by 2030, but I think that's a very conservative number. And that growth rate of 12.75%, I think, is going to get blown out of the water as well. So we need to start taking a look at the precision cooling, AI, high performance computing data centers in a different way. Some of the data center trends, I believe you all may know this: speed of deployment. It's not just speed of getting the product built and out the door, but it's the inside support that needs to respond quickly to all your needs. This will help us reduce supply chain issues and will help us with the integration of software. All the discussions have been centered around cooling and power, how to unlock the stranded power, PCE, power compute effectiveness, the infrastructure densification, and the eventual reduction of cooling and power infrastructure, which I'll talk about a little bit later. But the key to all this, for AirSys and for others, is not only alliances within the industry, working well with your supply chain, but also partnerships like we have with PLC for over 10 plus years. We're going to show a nice quick here video of our product set.
In today's AI-powered world, computing demand is exploding. Chips are smaller, faster, and more power-hungry, pushing heat density to record levels. But heat isn't the only challenge. Most data centers still operate with low PCE, power compute effectiveness, a key metric that shows how much of your power actually drives computing. To scale compute power sustainably, we must revolutionize cooling. Power One was built for this challenge, designed from the ground up to push PCE higher and bring heat under control. Meet CritiCool X, our high-efficiency, oil-free magnetic bearing chiller. Magnetic levitation tech slashes friction and energy use. Dual series loop with reverse flow maximizes heat transfer. Flooded falling film evaporators drive unmatched performance. It's efficient. It's quiet. And it's built for hyperscale. CritiCool X is modular and scalable, supporting up to 2.5 megawatts per unit. It deploys fast, installs flexibly, stackable or split, and adapts to your data center footprint. For more free cooling, meet Maxer, our high-performance fan wall designed for high water temperatures and large delta T. By raising return water temperatures to 36 degrees Celsius and supporting large temperature differentials, Maxer enables the use of free cooling, reducing reliance on chillers and lowering system installation costs. Meet direct-to-server performance. Enter Liquid Rack, spray cooling at its smartest. Up to 175 kilowatts per rack. Customizable 3D printed sprayers. 90% less coolant, lighter infrastructure, free cooling ready. Power One is adaptive, efficient, and built to raise your PCE, because true compute power shouldn't be wasted on heat. Welcome to the new standard in data center cooling. Welcome to Power One.
All right, excellent video. I'm going to pause here for a minute and ask before we get into some of the other product portfolios if there are any questions.
We do have one question in the chat Sean. It says the presentation mentions the size of 2 megawatt chillers. What are the dimensions for 500 kilowatt chillers?
Oh, for the
500
500.
kilowatt, 500 kilowatt and 1 megawatt.
Okay, so our 2 megawatt solution, I'll answer it this way first because it'll be on one of the slides, is no larger than 53 feet long, no higher than 10 feet, and about 7.5 feet of that size. If you were to go to a 500 kW unit, it would be half that size. So of that, but we would maintain the same width and height.
Okay, go ahead.
All right, so the Power One portfolio. We have everything from a dry cooler to our critical chiller to our fluid cool CDU to our Optimedia 2 chilled water. And at the end, I'll talk about our liquid rack product. But with that being said, our comprehensive suite of solutions are engineered for the next generation of cooling challenges within the data center, which means, shorter lead times for rapid deployment, less energy consumption and better performance, and eventually removal of compressors and being a compressor-free operation. Innovative designs to be able to be scalable for AI and high performance computing, going from today's legacies to those new technologies. Reduced environmental impact for us with lower PUEs and WEs. And of course, our global experience with a local presence. Not only do we have partners like PLC, but we also have the ability of a service network to support the units out in the field. We have two primary solution sets, one that each meets the need of a direct-to-chip solution, as well as a server-level liquid cooling solution. The first one, which is the direct-to-chip, which is the legacy type of products that we have, your traditional chiller, going to your fan wall or your large craw or small craw or CDU down to the rack level, right? Gives you faster lead times, higher chilled water, lower PUEs. And then we have our service level liquid cooling solution, liquid rack, with an improved PUE and PCA. And this is where we're taking a look at, the compressorless type of solutions, eliminating the CDUs and the thermal expansion tanks for the reheat. PCE, right? It's the new metrics that we come up with. We all know that PUE has been used for a very long time, and it has been a great metrics. But we have come up with this new metric since most data centers are built around compute nowadays, and we're calling it power compute effectiveness or PCE. It is essentially the amount of power allocated for compute compared to the amount of power allocated for the whole data center. So it's a new metrics that we are working along with PUE, but the PCE is more in line with how data centers are designed and built today, providing a higher, if the PCE is higher, you're going to get better efficiencies, you're going to get better utilization with compute. And as we all know, more compute means more profit and a quicker speed to market, as well as a lower CAPEX expense. Our critical product. This is basically our chiller set. We have the capacity of 500 kW, 1 megawatt, 2 megawatt. We're building this as well as we're seeing 2.5 megawatts, so we can do more in a smaller footprint. We have utilized the turbo core oil-free mag bearing compressors, our patented series counterflow product, adaptive cooling. We are also providing this with global warming potential ESG R515B refrigerants. And we have a standard modular design based off that 53-foot length I mentioned earlier, and fast deployment. We're looking at the ability to get chillers into the marketplace within 24 to 30 weeks. Here's a look at the footprint of our 2 megawatt chiller. As you can see, as I mentioned, it's 53 feet in length, 4 compressors, 2 pumps, 7.5 feet wide by 9.3 feet high with the fans, a little bit smaller with without the fans. We've designed this specifically so we can put it on a 53-foot long truck, which means that a couple things. You don't need to have a special route, or you don't need escort services to get the unit to the site. And secondly, once it's on site, the rigging of it is a lot easier with one solid piece being put in place, which means less connections for the mechanical contractors. Our fluid cool CDU. Again, this is engineered with space in mind. It's designed to fit right into a row of enclosures if necessary. It comes in 3 different capacities: the 500 kW, the 1 megawatt, and 2 megawatt. We did this specifically to match up to the chillers, but we're also designing, because we know everyone wants to go bigger. And we're in the midst right now of designing a 3 megawatt CDU, and we are talking to clients about customized larger units up to 10 megawatts. But the nice thing about this product, it's hot swappable components, 99% front accessible for any type of service needs if there's an issue with the unit. A number of different, not only leak detections, but also internal detections for inside the steel. And we're using a stainless steel 316 to help mitigate any type of degradation to the fluid inside of the CDU. Just a little schematic picture of what one of the skids might look like. This is a one pump, 3 megawatt design that we're looking at with 2 heat exchangers. Comes with an expansion tank. But again, this is something that we at Aersys are innovative enough and understand enough that the clients are not put into just a box, right, and off the shelf. We have the opportunity to speak with you and understand what your needs are. Our fan wall, the Max Air. Again, this is another product that is scalable. It comes shipped in 2 different pieces. It has quick connect, low voltage electrical components, so you can easily put them together. There are some high voltage connections that need to be made by a certified electrician. However, this design and this modularity gives us the ability for rapid deployment. It's maintenance free. It comes with Corel controllers for monitoring. The cooling capacity is 720 kW plus and over 90,000 CFM in a small footprint ranging from 84 feet to 140 feet wide with standard depths and heights. Then we have our OptiMedia 2 chilled water product up to 240 kW. This product is truly an offset of our Crack Unit DX Optima 2 product set. It comes in modules, so you can build it in 60 kW and add on to it to make it 120, 180, and 240 above. Again, this modularity gives us the ability for rapid deployment, front and rear accessibility, so you can put them right up against each other. And they come in a number of different configurations: downflow, upflow, front discharge, rear discharge. Piping is unhanded, so you can come in from the top, the bottom, the left, or the right. This is our OptiMedia 2 chilled water high density. This is a one frame solution as opposed to the smaller 60 kW modulars. We have different capacities of 400, 600, and 800 kW, where we're getting up to over 90,000 CFM or 1 megawatt of cooling. Again, this is a product that ships in 2 pieces, the coil section and the fan section. You have the ability to run higher entering water temperatures. This gives us the ability to, again, rapidly deploy, which is the theme for every data center. But again, it comes in the ability for us to address your particular needs depending on what your cooling requirements are. Our DX unit. This product has been around for 12 to 15 years. Again, it's based off of the unit with the modules. However, these are in 40 kW blocks, and you can get up to 240 kW. It comes with a heat rejection condenser. It can be either out on the roof or outside the building itself. Highly efficient. and it already comes with the R454B global warming potential of 466. Again, this will fit right through standard doors, standard width and heights of those doors. So it's easy to move and quick to install. Our liquid rack product. This is a product that is what we're calling a spray immersion cooling technology. So when you think of immersion, the traditional one is like a bath. Think of this as a shower. We have the ability we've created, I should say, a new category within the industry, which is called, the server cooling at the rack level. This product comes in number of different sizes, but the standard size is a 10 cassette, as you can see there, in almost the same footprint as an enclosure. With that being said, this can stand alone within a data center, or it can be placed into a hot aisle, cold aisle solution. These cassettes are removable by a trolley. So if you have an issue with one of the cassettes, or you need to replace a cassette, it has quick disconnects in the back, both for the coolant, the fluid, as well as the network and power. This product is one of those products that's really hitting in the industry in a different category. The cassette itself, as you see here, again, is a spray. So what you are looking at is at the bottom is a little tub that catches the dielectric fluid as it showers over the GPU or CPU. It is then moved into a pump, which the pump then moves it into the heat exchanger, where the facility water, which is on a separate loop, then removes the heat, and then it's just pushed right back into the chip. So it's that evolving. And it goes back to the discussion I mentioned earlier about compressor free. We're looking at this as a important product set where the traditional design has been chiller, fan wall, craw, thermal expansion tanks, thermal energy storage tanks, and then to the rack itself. This eliminates all the mechanical stuff in between. So it goes from the dry cooler direct to the liquid rack, or the chiller, depending on your temperatures, direct to the liquid rack. And I believe that is, Jacques, the Power One portfolio from Aersys in a nutshell.
Thank you, Sean, for introducing us to the Power One cooling solutions for today's data centers. I expect a lot of queries on these from our audience. Before we go to our Q&A session, let me share with you a short video on a few implemented solutions we in Canada have done with some of our customers.
As modern computing power climbs, mission-critical infrastructure faces a silent, escalating threat: massive equipment heat loads. When standard commercial cooling systems try to absorb that kind of intense thermal output, they stress, degrade, and eventually fail. If the heat isn't managed, the hardware stops working. PLC Group designs the specialized thermal management strategies required to handle these extreme environments. Our approach is built around 3 goals: protecting critical operations, reducing the physical infrastructure footprint, and driving down lifecycle costs. Addressing these thermal limits removes a major barrier to uptime. Since overheating is a primary cause of system failure, stabilizing temperatures is a necessary step toward long-term reliability. Take this Canadian radar system. Operating in a harsh, remote environment, the equipment inside these containers generated a localized heat load of 180 kilowatts. To counter this, we engineered a specialized cooling solution directly integrated into the radar shelter, utilizing 6 Aersys Unicool Edge units. This chart compares the baseline heat load to the new system's output. While equipment maxed at 180 kilowatts, our integration delivered 240 kilowatts. This differential creates 30% thermal headroom, a safety buffer for operational spikes and extreme weather. By building in that margin of error, we secure reliability for defense systems while keeping the deployment at a cost-efficient price point. Physical space is often the primary constraint. A leading broadband provider dealt with failing legacy cooling equipment trapped inside a cramped telecommunications Communications head-end facility. We introduced 3 AirSys OP2 40 kilowatt modular C-Rack units. These were engineered to fit within the existing footprint while delivering twice the cooling capacity. This schematic shows the new airflow routing. By utilizing variable frequency drive compressors and optimizing fan speeds, the new modular units integrate directly into the pre-existing legacy ductwork. Because we reused the current ductwork, we eliminated the need for new infrastructure construction, achieving a 30% faster delivery time. Bypassing those spatial limitations restored network reliability while generating significant capital and operational savings for the provider. Then there is the challenge of scale. We were tasked with fully outfitting a 4-megawatt data center within a rigid 4-month deployment window. To meet that deadline, we installed 6 10-ton variable AirSys Unicool WPU units, assigning 1 unit to each of the facility's 6 UPS rooms. This vector graphic demonstrates free air cooling. During cooler months, the system draws naturally cold outside air, allowing mechanical cooling to power down. As the graph shows, this resulted in a 90% reduction in cooling energy required. Using environmental air for cooling makes high-density data centers more sustainable, simultaneously lowering their carbon footprint and reducing ongoing operational expenses. Instead of fighting constant thermal threats, these facilities now run consistently cool and efficiently. Through targeted engineering, operators gain rapid deployment, capital and operational cost reductions, and mission-critical stability. Thermal limits and equipment heat loads should no longer restrict your technological growth. Future-proof your critical infrastructure today by partnering with PLC Group. Visit plcgroup.com to see how we can help you manage your facility's heat loads and reduce your thermal risk.
Okay, thank you very much for watching this video. Now we're going to take some questions or answer some questions. Here's a question. Okay, Sean, here's a question for you. What is the lead time for your liquid rack product?
We are anticipating, since we are still in the testing phases of a 2026 Q4 deployment of our liquid rack.
When will the Woodruff manufacturing facility be producing the full Power One product portfolio?
Again, the factory opens up at the end of May here in 2026. We are anticipating that we are going to have all of our production lines on the Power One portfolio up and running and delivering products at the end of Q4 of 2026 into 2027 of everything we manufacture. But between now and like June, July, we are still transitioning a lot of the product sets from China to here. So some of the orders that we're currently taking right now for delivery in early Q3 of 2026 is going to be coming from our Chinese factory at that point. But once Q4 hits, it'll be 100% from the production facility in Woodruff.
Okay, here's one from Paulo. Hi, Sean. It's projected that up to 90% of the AI workloads could be interference-based by 2030. How is AirSys designing its edge cooling solutions to handle the power density and thermal density variability of interference workloads, which tend to be bursty rather than sustained?
Okay, so I'm thinking that that's at Paulo at the chip level that you're looking at on the AI workloads, and how we're thinking of doing it is that with the liquid rack solution and eliminating a lot of the compressor free is one way of taking a look at it. The other way, a more traditional way, and it's the way that it's being done right now, if I'm answering the question correctly, is that we're seeing people still utilizing chillers to the CDU, to some sort of rear door heat exchanger solution with an in-rack type of two-phase CDU product to get up to those particular density levels or power density levels and thermal density levels within the rack.
Another question from Paulo is, on Power One, with water usage becoming a mounting ESG concern in data center operations, how does AirSys liquid cooling technology balance thermal efficiency with water consumption? And are any of the Power One units designed for closed loop waterless operation?
Right. So our dry coolers and our air-cooled mag bearing chillers are both closed loop designs, and resulting in, with no evaporation, resulting in a zero WUE. I believe with that, and as well as with the liquid rack being a self-contained closed loop solution, our WUE will be very, very low, if not zero.
Here's another one from Wissam Qureshi. If we have a server that's not compatible with liquid rack, how do you address it?
That's a great question. The How do we address the server? So what we're doing right now is we are engaging with NVIDIA, AMD, and other server manufacturers to purchase those servers and to test those servers. If you currently have a immersion ready server, we can make compatibility arrangements for that today. But as for some of the others, we are working with the chip manufacturers and the server manufacturers to ensure that our cassettes within our liquid rack are compatible.
I think you should also know that the liquid rack. I'm not to you, Sean, but to Wissam. The liquid rack is designed. Each cassette is designed for a specific server because the heads that are spraying directly on the chipset, those are 3D printed. And so there's a 2 to 3 week testing period where you take the new server and you print out the new heads, and then you're able to run some tests on your solution cassette for that server. And then once you're comfortable with the solution, then you invite the server manufacturer to come in and approve the test and approve the cassette for a solution for their server. Am I correct, Sean?
Yes, you are. Correct.
Okay. So one of the question was, why is PCE important?
Well, because when you have a good PUE, you still waste massive amounts of available power. The PCE exposes the stranded power. The data centers you can build the same data center with the same PUE, and they can have drastically different PCEs. When you think of PCE, think of the allocated power to compute rather than you cooling the equipment, which drives us to designing better HVC equipment for the data center. That's why it's important. You want to be able to get that stranded power, so to speak, which is in the compute side. And as we all know, compute means money.
And on that same token, by building a data center in a modular fashion allows you to have a higher PCE, because as your data center grow, or as their heat loads grow, or as their IT load grows, you just keep on adding more chillers or more batteries or more it's completely modular. So you keep on adding more modules, and then that maintains a high PCE, and you're not forecasting all the capital expenditure on a data center that you don't even have the IT loads yet, and you will maybe in 5 years, but right now it's all capital spent for future loads.
That's true. That's true, Jacques.
If we need 50 megawatt chillers installed, what kind of spacing between each 2 megawatt chiller is required?
Well, it depends, right? So we do the air-cooled chillers, mag bearing, and typically you see 6 to 10 feet between the units to prevent, any type of hot air recirculation. Clearance usually above the chiller, you want to see about 8 to 10 feet of unobstructed vertical space on that. And the units placed end to end should be about 10 to 15 feet between the discharge faces, if that answers the question for you.
I think that does. What is the frequency of filter maintenance, and is there any alarms?
Well, the frequency of filter maintenance is really dependent upon the site It's dependent upon the facility. But there are built-in alarms within the controller to identify when a filter is about to fail. So that can be built into the sequences of operations and stuff like that within the controller set.
Here's a question from Mark Hanjani. Rack density for AI DC is over 100 kilowatts. How would server level liquid solution integrate? What is your experience on, say, 5 megawatt data center and building footprint required to accommodate?
Well, that's a great question, but because we really haven't deployed the liquid rack in scale, that is a site discussion that is going on currently. Like I mentioned earlier, you've got a chiller to a CDU to a rear door heat exchanger. What is the evolution of that going from a 100 kW rack to, let's say, 220? That is something that we quite really haven't solved yet without saying that, hey, you're probably going to have to replace that rack with a liquid rack if you're going to those higher densities. So it's a great question. I don't think that was a great answer or the answer you want to hear, but truly at the end of the day, going from 100 kW upwards to 200 in a rack that's already in place, the rack might just have to be replaced.
Okay, here's another question. Just adding, using environmental cooling for HVAC. That's amazing initiative as worldwide companies are now moving towards green, sustainable data center. Oh, this is just a comment. Okay.
Okay.
Sorry about that. Rack density for AI DC is over 100. We just talked about that.
Yep.
How does the AirSys cooling system optimize energy efficiency in telecom sites, particularly under high ambient temperatures conditions, and what measurable impact does it have on overall power consumption?
I think that's a question for you, Jacques, because it's the telecom sites, and I particularly don't have a lot of experience within a modular telecom area, Haroon. So I apologize, but I think Jacques, that might be on your plate.
So what we do for that, Sean, is that let's say if you need 10 kilowatts of cooling, we give you a variable compressor 20 kilowatt unit, and then as you so you start off at 50% capacity on the 20 kilowatt unit, and as you add more heat load, the compressor just speeds up to match the load. And at some point in time, if you know that the 5-year plan for that site is not 20 kilowatts but 40 kilowatts, then you can plan on putting in another 20 kilowatt unit alongside it in 2 years, kind of thing. And then that way both units can run together at a minimum speed to match the load. And as you increase the load, both units would speed up incrementally to both tackle the load. And you have to also realize that if you want N+1, then you have to make sure that one unit fails, the other unit can handle the entire load. So we would have to look at that design criteria, and at some point in time, you need to make some decisions on when you want to install another unit to make sure that you still maintain N+1. Here's another question by Moid Boyan. We have an e-house with MV switchgear, VFDs, etc. The total heat losses amount to about 200 kilowatts. So yeah, 200 kilowatts. Which system can be used for this type of application?
Okay, so again, this is outside the traditional data center, and I believe you're referring to like powerhouses, Mohad, in regards to that. It depends on how big that e-house is. If it's a larger e-house where we can fit traditional DX units or chilled water units in there, you could deploy a small 500 kW chiller to that with internal cooling in the space, or you could utilize the Unicool Edge, and I would defer that really more to Jacques' side of it or PLC side of it, because I'm not the Edge One guy. So Go ahead,
Yeah,
Jacques.
so I'm going to add my 2 cents to that too, Mode. We have, like I was talking about, for the unicool units, we have the wall-mounted unicool units, the 10-ton. So each unit can provide up to 35 kilowatts of sensible cooling. So I would propose to put 6 of those or 7 of those on an E-house. But we also have the unicool edge units, and you can mount those on the end of your e-house. And if you have enough, I don't think e-houses are built with hot aisle and cold aisle containment, but if you can space your equipment accordingly, then we can treat your e-house similarly and just blow the cold aisle where it needs to be picked up, and then after that have some kind of maybe ducting to get the hot air back to these units on the other side. We can work with you on this. We can propose a design. We can have Airasys look at it to see how well it could work, and then I think you'd be happy. We can also do a simulation to show you how it would work, and then after that, once we do all of this, I think you would be happy with the end result. I think we have another question here. Hi, Sean. I have another question. Any maintenance and monitoring options available with Airasys units in a cooling as a service setup?
Yes, there is. And we can talk offline on that one in particular, because as we're starting to roll out and deploy products, we are engaging in service partners to help us with the cooling as a service, so to speak, as part of our services components or preventative maintenance programs.
Thank you. What role will AI play in optimizing cooling systems in large-scale data centers?
I think that's a great question as well. But I think it goes to AI being utilized in data centers for predictive thermal management, understanding where some of the hotspots are, predicting where they'll be. Maybe reduce any type of thermal throttling events that may occur. Also, continually checking, the set points and fan speeds and pump flow rates and being more intuitive in regards to the runnability and the efficiency and the sustainability within the data center. So I think AI is going to play a very large role in the optimization of cooling systems, not only for enterprise and co-location retailers, but also for the wholesalers and the hyperscalers. Mohammed, that's a great question, but I think it's going to play a very large role as it continues to evolve.
Is there any particular maintenance required for liquid rack?
Just the regular type of maintenance in monitoring and understanding if there's any degradation in the dielectric fluid. Every once in a while checking the heat exchanger. So there are some predictability maintenance that needs to be done with the liquid rack. It's not just plug and play and let it go until it dies. There are abilities to monitor with sensors. The quality of the dielectric liquid and what else is going on with the pumps and the heat exchangers. So it's really, that type of maintenance that you just want to take a look at like you would do with a traditional DX unit.
Is there like a car is expected to have an oil change at 10,000 kilometers? Is there something similar with these liquid racks where the dielectric has to be swapped out every couple of years?
Yeah, there is. But to be honest with you, I don't know what that switch out would be. If it's every 6 months or if it's every, year or so, like a car. What we do is we do put sensors in there so that you can be preventative in your, in your review of how your product is performing or how the cassette is performing.
Here's a question that says, is there a way to adjust cooling capacity with Airasys units based on varying workloads in data centers?
Yeah, that's really a function of the controller set, right? So it depends on, again, going back to what sequences of operations you want to see within your controller. At what time of day do you want to, ramp down fans? What time of day do you want to ramp them up? And so there are various ways to adjust the cooling capacity with our units, and it starts with the controller.
Can AI predict cooling system failures before they happen, and how does that impact data center uptime?
It's going to be the same thing as Mohammed's question earlier in regards to AI's role in predicting and participating in the maintenance area of the data centers, right? It's what you want to put into your GPT or Claude or Teamworks or whatever one you're using, but it can also help identify those particular system failures, understanding when certain units like fans, motors, are they overheating? I think AI and some of the software systems that are out there have that predictability not only now, but it will be enhanced in the future.
What are the common challenges faced during the deployment of AirSys cooling systems? What best practices are recommended to ensure optimal performance?
Right. So always some of the common challenges of deployment is very sometimes site specific. Sometimes getting to the site, sometimes the partner may not have measured correctly. It's the best practices for optimal performance is ensuring that the pipe lengths, pipe runs, pipe diameters are all within the IOM manual for the product set that we manufacture, and that it conforms and it's not outside of the requirements that we have for our product set. So it's the common deployment issues are sometimes there are too many turns, especially with DX units going to the condenser for heat rejection. Too many elbows. The length run is over 200 feet in length. So it's certain things like that. If I'm answering your question, Harun, correctly. But those are some of the challenges we face are more site challenges and more installation challenges than anything else. When the unit arrives, the pipes there ready and is it ready to go? Is the power set and the unit powered up when it's supposed to be? So those are just some of the common challenges that we face on a regular basis, just like any other manufacturer would.
So it looks like that's it for questions and answers. Just want to remind everybody that this presentation will be shared with you by email along with the link for the webinar recording and the questions and answers within 48 hours following this webinar. Just want to thank everybody for attending this webinar. I hope you found this presentation informative. And there's a QR code on the screen that you can scan if you want to have further discussions with us. And that'll provide you with our contact information. Thank you very much.
Thank you, everybody. Appreciate your time.